Very good.
That's the sign that we got to go.
You're quite musical.
Yeah, well, I can play this. All right, welcome back to the morning show. It's 7:25, part 2 of our Wise Guy segment. Matt Sullen, our U of I physics professor, is here, and we're talking about sound.
Right, so the thing that determines a pitch is two things. There's a very simple relationship between frequency, wavelength, and speed of sound in whatever gas you're talking about or material. And so it simply is that the pitch is proportional to the speed, how fast it travels, divided by the wavelength. So if you have a long wavelength, you have a lower pitch. And that's why the question yesterday was about the dogs and stuff like that. So the wavelength you tend to produce tends to be sort of related to the size of your voice box, the size of whatever's making it, like this thing. So if you have a little tiny thing, it makes a shorter wavelength, so you get a higher pitch. And so I know you're just... I'm actually really aching to hear you talk like Donald Duck, so we're gonna show that the pitch goes up when you increase the speed of sound, and helium has a larger speed of sound than air does, so I'll let you do this.
Okay, Mats. How's that?
Are you getting dizzy yet?
No, not yet.
Good. That sounds excellent. Okay, so now you have a much higher pitch when you do that because the speed of sound in helium is significantly faster than the speed of sound in air. Now, if you take a big, deep breath, you should be back to normal again.
Well, my voice will be back to normal.
Yeah, that's right.
I don't know about anything else.
Now, we have some other things here that make interesting sounds, and I just wanted to touch on these because they're kind of cool. So this is like these xylophone sort of things.
Right.
And the thing that's interesting about those, if you ever play with one, is if you hit it and then you touch it in the middle, it stops making a sound right away. But if you touch it over where the supports are,
it keeps going.
It keeps going, okay? And that's because the thing actually vibrates. Imagine your fingers are where the two supports are. The vibration of that piece of metal is kind of like this. And so where the supports are, it's actually not moving up and down at all. The middle and the ends are moving, but right where it's being supported, it's not moving, so it doesn't matter if you touch it there.
Cool.
And here, so you have this wave which is kind of happening because this piece of metal is bending up and down a little bit. It's so fast and so little that you can't really see it. But I have this other thing which I showed you before, which is really cool. It's just a piece of aluminum. And instead of getting a bending wave on it, a transverse wave, we're going to get a compression wave going on this thing. Okay? And so what we're going to do is I'm just going to put a little rosin on my fingers. This is just rosin like from a violin rosin. I'm going to hold it in the middle, which happens to be where the node of vibration for this mode is, so that I don't kill the vibration. And I'm just going to rub this thing with my fingers. Isn't that annoying?
That's loud.
It's very loud. And I can stop it just by grabbing it right there where the thing is vibrating back and forth.
We got about 30 seconds left. What else you want to show us?
Oh, cool. Okay, well, so we're going to come back next week and we're going to talk about some other things that were suggested by viewers.
Okay.
One is a Doppler effect, the thing that you hear when a car goes by. You know, the pitch changes, which is kind of neat. We'll talk about echoes, and we'll talk about sound, whether or not it can traverse space.
Wow. And just a point of reference, we were talking about the speed of light and the speed of sound, the difference again?
Right, so the speed of sound is about 300 meters a second, a little more than that. The speed of light is about 300 million meters a second, so light travels about 1 million times faster than sound does.
Very good. Puts it in perspective.
Through air, yeah.
All right, Matt Sullen, thank you very much. If you would like to watch us again later or send an email to Matt, you can send it to the morning show at wcia.com.
Or you can go online to wiseguy.net. We'll be back with more of the morning show right after this.